All right. Thank you for joining today. My name is Alexander Sokol, and I will presenting a WBS workshop on building reliable AI-based workflows. Today, we plan for a 90-minute recording or presentation, which will be fully recorded and later made available online. As we already heard, the participants will not be able to unmute. However, would like to welcome any questions. And the way that we're normally doing it during this workshop is please feel free to put questions in the chat. And then my colleagues will summarize them in a separate window. So I have a separate device on which I'll be able to see the chat because I'm sharing the screen. And I will answer them from time to time as they come. Hopefully, we don't need to wait until the end. I'll find the right moments during the presentation to answer any questions that come up, but I may not be able to answer them right away as soon as they're asked. Today's workshop, which is for 90 minutes, consists of two parts. And the first part is theory, right, where we'll look at some of the theoretical underpinnings of what we'll be trying to accomplish. And in particular, I will touch on maybe a somewhat unexpected subject, which is the psychology of LLMs. And yes, LLMs are more like humans than like robots. They actually do have psychology. I will go over some of the things that we need to worry about, which many of them you're actually already familiar with, even though you may not think of them as psychology or biases or cognitive biases or other things that are more, perhaps appropriate for humans. But whatever the terminology, we're clearly observing behaviors in AI that is very, human-like. And this is actually not unexpected because AI learned from the body of content that's created by humans, and unfortunately learned some of the biases that we have. And these biases are seeping to our workflows and our business use of AI, and in some cases they help, or can be harnessed to help, but in many other cases, or most of the time, they actually are harmful and reduce reliability. So a lot of today's presentation will be about identifying these biases and overcoming them. Right. So before I continue, I want to make sure that I'm sharing the right screen. So you see the slide deck, right? Right now.
We do see the slide deck.
Okay, that's perfect. All right. So first of all, again, before I proceed, so we're actually trying to make research available as open source. So there is a repository on GitHub that has some of these experiments that I'll be talking about and many more. So we'd like to encourage everybody to download and try it. And some of the actually results are quite fascinating. And also we have, for those who are not in the mood, to code, there is also a playground where we're going to, after the workshop, we're going to post this experiment, so you'll be able to log into this playground and review the results online, basically in the browser window, which is another way of looking at them. All right, and with that, there's a LinkedIn page where we'll be posting updates on the project as we have been in the past. So please follow the LinkedIn page if you're interested in this research or any follow-up research that we'll be posting. All right. So first of all, achieving reliability, right? So why are LLMs? Why LLMs are like humans, right? And this is actually very critical point here. And I think that we're all kind of no longer shell-shocked from the way that we were when OpenAI came out with ChatGPT a few years ago. Where the concept of talking to a computer program in natural language was totally, like mind-boggling, right? That you can do that. And now we're a lot more used to the concept of AI providing verbal responses in natural language, of prompting, right, which is providing verbal instructions. So we're no longer, in shock of this whole concept of this thing that seemed like science fiction only a short while ago. Especially, perhaps for those who are not following the research closely, right? Because this was clear, it was coming, right? But I think for the general public, and I think me included, and certainly many in the finance community, it was very surprising how rapid the progress was made. So, however, the fact that AI performs like humans and not like programs, I think is still perhaps did not fully, is not fully appreciated. So in other words, we are used to talking to AI as in natural language and asking, please help me with this, right? But rather than writing a computer program, but all at the same time, I think we're talking to AI, and I'm using the terms LLM or AI interchangeably, right? So we're talking to AI in natural language, but we're still not treating it as a human, right? We're treating it as a computer program. And that's actually a very dangerous misconception that they will, respond like a robot, right? Because it could cause us to miss some of the pitfalls or some of the dangers when we use it for business workflows or business purposes, and we may end up with unexpected results and reliable results, right? We may end up with hallucinations. So it's very important that when we are trying to understand AI, we try to understand it as humans, right? So in other words, when AI does not do what we expect, we need to think, well, what will a human do, right? What will human response be in the situation? I think that that's a very powerful way to think about it that's extremely helpful in practice. All right, so now the strengths and weaknesses, right? So strengths of AI, right, and of humans, of course, right, is the ability to process unstructured text, sound, or images, resilience to input format changes. We can use logic to follow imprecise instructions, and AI can as well, right? Now, the weaknesses of humans in AI is our cognitive biases, right? So, namely, inherent variability of response, limited recall, and cognitive biases, which I put first on this list. And this is something that we'll be focusing a lot on today. All right. So now the biases, there are many biases that psychologists and also economists actually use. And for the background reading on this, I think that there's a large body of research and books by Daniel Kahneman, which I highly recommend. Right, so that's a very good introductory text. But also there are a lot of research that as quants, I think we can. I don't want to be arrogant and say we can easily understand psychological research, but we do have a big advantage. If somebody tries to read quant papers, I think they'll get lost a little bit on the formulae and jargon, right? So psychology, at least you can understand exactly what they're writing, right? Maybe we will, as non-experts in psychology, miss some nuance, but at least when the psychologists describe an experiment, we can understand the experiment. Whereas as quants, when we describe a model, right, I think for non-experts will be hard to understand it. So I would like to encourage everybody to read papers on psychology, because when we work at AI, actually some of these behaviors are really right out of the book, right? So in other words, something that was proven in a well-controlled psychological experiments with humans, we actually were able to reproduce with AI in our research, and we will be publishing this on our open source page. So there are innumerable biases that psychologists study. Also, some of these biases are related, and some of these biases are particular cases of other biases. So I'm not going to spend the next 2 hours or hour and a half talking about biases, because we do want to get to some practical applications like trade entry. But I selected 2 biases that I would like to focus on, that I think that are tremendously important to understand if we want to use AI and achieve reliability. So one of them is framing bias. Another one is distinction bias. So framing bias is the kind of granddaddy of all of the other biases, right? So that's a key thing that we need to understand about AI. That's the strongest bias, right? For the reasons that I'll explain in a moment. Distinction bias is actually something that I put it on this list because it's a bias that we can harness, right? So in other words, framing bias, it can only be harmful, right? Or most of the time is harmful. So we don't want framing bias to occur. We want to take steps to avoid the framing bias, as well as all of its cousins and particular cases like confirmation bias, halo effect, etc., the Dunning-Kruger effect. Right, but we also, can harness or take advantage of some biases. So distinction bias is a bias that we can actually use to our advantage. Right. So let's start from a framing bias. So framing bias is the dependence of the answer on how the question is presented or framed, right? Psychologists have a more formal, precise definition, but that's a kind of layperson definition, right? And it's closely related to a few other biases, confirmation bias in particular. And the model learned these biases. So why these biases occur? There are kind of two schools of thought on that, right? So I think that this is kind of almost like one and the same, or they are closely related, sort of like different interpretations of quantum mechanics. I'll say not even closely related, but I would say it doesn't matter how you interpret or how what do you think the reasons for these biases are. It doesn't matter when you're trying to use AI; they manifest the same way, right? So just like quantum mechanics will make the same prediction, you can think of different interpretations of quantum mechanics, but in the majority of cases, the prediction will be the same no matter what your interpretation is, right? So same thing. So there are two ways to think about where these biases come from. So one is that the biases were learned from the body of content that the models learned from. Like, and some of it is clearly the case because, for example, Llama model has a little bit different type of biases from OpenAI model because Llama models were trained by Meta on Facebook and Instagram discussions, right? So on all of these threads that are open and can be scraped. So meta models, they have a little bit different biases based on the body of text that they've been trained on. Whereas OpenAI models were slightly different. They behave a little bit different because they're trained on a different. So each model vendor has a different source of data to train the models on, and you can see that they're a little bit different. I think it's not just the model architecture, but potentially it's training data. But also, a lot of these biases, I think, just have to do with the way that the human mind works and the way that these enormous neural networks that work inside AI. And I am actually of the opinion, right? And there's clearly a lot of debate on that. And I hope we don't need to spend the next hour arguing about this. But there are some very heated discussions going on about whether AI is really reasoning like humans are reasoning, just perhaps not at the adult human level, or maybe already approaching it. Reasoning like a child or a teenager, right? Or whether it's just a parrot and it's just the appearance of reasoning, and in fact, it's not just like a parrot can repeat human speech, but really probably doesn't understand much of it. So there are two different thoughts, right? So one is that the models really reason like humans, that these neural networks are wired similar to the way that human brain is wired, versus the view that it's really just a glorified search engine. But these biases are clearly present. You can prove it with experiments, right? And we did, if you look at this open source project. So no matter what you think about whether the human brain and neural networks inside language models work the same way, just perhaps language models are just not is big enough yet, or work fundamentally on a different basis, right? So these biases either part of the architecture of the brain and the neural networks, or they've been produced by the brain and learned by the neural network from the content. Doesn't matter. These biases are clearly there. We see them in pure experiments to identify, designed to isolate the biases. We also see them indirectly in the way that AI makes mistakes, right? And the way that it malfunctions or doesn't do what we expect. So it's there. So we need to, no matter what you think about its origins, we need to learn how to control it and how to harness it when we can harness it. All right, so classical gain versus loss framing. So that's an experiment which is actually equivalent to a well-known classical psychology experiment where a human, right, prefers a gamble or what's called, there's something called prospect theory, a prospect, right? So the proper science term for it is prospect. So a human prefers a prospect with higher likelihood if it's framed as a potential gain. And exactly the same economic outcome will be rejected with higher likelihood if it's presented as a loss. So let's look at these two things, right? As a trader neutral to risk, should I pay $X for an overnight option that has a 5% chance of expiring in the money, in which case it would pay me a much higher sum of 100, no much higher sum than X, right? So now notice that I set trader neutral to risk to reduce, even though it doesn't completely avoid it. Still, the model, as we will see in a second, will assume some risk aversion, but I'll try to at least tell it not to, right? And also, I said overnight, right, which means that first of all, the shorter the the shorter the horizon, the less is the risk aversion, right, or perception of risk aversion rather. Actually, it only depends on the outcome, of course, but generally, like short term, less risk, right? So we're trying to do that. But also more importantly, I was trying to avoid any adjustments for the interest rates. I didn't want the model to start thinking about what the interest rate is to see like how this future sum of 100 compares to today's $5, right? So that's one way to frame it, right? So I'm paying for an option, and the option can bring me a lot of money, right? Or should I enter into an option strategy? By the way, psychologists actually do it as a gamble, right? So, we're in the financial industry, and I was trying to do something again. So this is, of course, nobody is going to be asking these questions, right? But this actually can be manifested in reading sentiment, right? So in other words, there are some real practical situations where this framing bias may actually have direct relevance. So, but of course, this experiment is just purely designed to isolate it, so nobody would be asking this question in production on AI-based system, right? So the second option is, should I enter into an overnight option strategy that has 95% chance of a $X loss and only 5% chance of a $X 100 X gain? By the way, this X, of course, is not going to be in the question, right? So I'm going to substitute, I'm going to ask $5 for like $5 loss or $95 gain, $10 loss, and $90 gain, right? So in other words, when the question is asked of an LLM or a human, X is substituted for the actual number. Okay, so we can observe here that econs are hypothetical, econs are hypothetical. So econs are hypothetical, fully rational subjects of classical economic theory. This actually is a term introduced to economics by a well-known economist and psychologist. And this is actually a wonderful way to think about it. So econs are fully rational. They're not subject to any biases. If you ask a particular question, they will answer the same way no matter how the question is asked, right? So this econs is what classical school of economics, until I would say relatively recently, until maybe 10 or 15 years ago, econs is what economists, so classical economists, assumed humans are. And surprise, they're not. Okay, they're absolutely not, right? So in other words, and we know this every day, right? So in fact, any scientific discovery seems obvious in retrospect, right? This seems kind of obvious in retrospect, right? We know every day we're making economic decisions, which really are totally based on framing and don't make really a lot of sense. Like, for example, buying insurance for a loss that we can easily afford, right? Like this type of thing, right? Even though, of course, we know that on average we will lose money because otherwise the insurance company will not be in the business, right? So I'm not talking about catastrophic loss, but buying insurance, like whatever, let's say car collision insurance, right? Really, logically, anybody who has money to pay for repair should not be buying it, but people just don't like the loss. They don't like feel, a scratch right now, you have to pay a lot of money. So humans are not econs. And because for an econ, the two prospects, and for this econ, right, it's these two prospects that we had in the previous slide are equivalent, right? So if you think carefully, right, both of these prospects have two outcomes, right? 95% chance of losing X and 5% chance of gaining 100 minus X. But first one is framed as a potential gain for which I pay the price up front. Second one is framed as a potential loss. And also, you see, I'm saying only 5%, right? So I'm saying, well, there's a gain, but like it's only 5%, right? So it focuses attention in a second case on the loss, right? So there's a word loss that surfaces, and that's actually, again, a science term about some knowledge or training in the model that becomes accessible as a result of a particular prompt. And priming or framing in case of humans, right? You say the word loss. It evokes perhaps memories of unfortunate gamble at a casino, or you take a risk on something, a trade, didn't work out, right? Only a 5% gain. I think, yeah, this probability is really small, right? Whereas the first one say, wow, 5% chance of gaining 100, right? It's the last thing in the sentence. It sounds really positive, right? So this is a classical thing that pays on humans. So humans prefer the first gamble to the second one by a huge margin, right? Even though they're economically identical. Well, surprise, right? So it turns out that humans and AI are not like econs, right? So you can't, you would think that AI would be in the econ camp. No, econs are lonely in their camp, sitting by the campfire, nobody joining them, right? Human AI on the other side, humans and AI are alike, we're brothers, right? So, we react the same way. So that was, something that kind of we started to suspect. So at Comparable, we've been doing a lot of research in AI just, as part of the job, right? So which started notice that, some of the things that we're observing how AI misfires are like surprisingly human-like, right? So like desire to please and so forth, right? So well, when we finally decided like, why don't we try to reproduce the classical psychological experiments, right? Not surprisingly, we found actually very similar results. There are, by the way, I don't have time, unfortunately, to cover it today, but we're going to post it on open source on LinkedIn. If you follow the page, it's going to be there, like within a week probably. So it turns out there are actually some biases that AI has that humans don't. Like for example, there is something called repetition penalty, and so which prevents AI from repeating the same word all over again, right? So that's actually without it, the model just keep repeating the same thing. There are actually mental illnesses which cause humans to do the same, right? And AI has a protection against that. What happens is that AI is actually feels very uncomfortable. And again, I'm not afraid to use like human-like terminology here. AI is very uncomfortable repeating the same word because of this repetition penalty, like pinches it basically every time. So what's interesting is that if you humans have a more sophisticated mechanism apparently against repetition penalty, because humans are not afraid to say yes, 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 right? AI doesn't like it. So if you ask for evaluating, let's say, 15 different things, it will be compelled to find one of them that doesn't fit. So it just doesn't have to say yes in a row, right? Same thing is that when you're reading a schedule, and all of the notionals are the same in amortization schedule for a while, it starts deviating from it. It doesn't like regularity, right? So that's not a human-like behavior. Or rather, humans have perhaps a more sophisticated mechanism for avoiding this bias, right? And it's more pronounced in AI. So there are some differences, but by and large, it's really we're finding exactly the same behavior from AI as we have from humans. Okay, so now the the biases that sorry, let me just go to the slide and I'll come back to the previous one, right? So this is what we're observing with the models, right? This is actually the most rational model of all, right? And this is the least rational, so which is mini model. So these graphs represent the probability or the fraction of yes responses to a question like, would you undertake would you pay let's say $5? So this if the point is at $5, is the answer is the fraction of the answers to the question, would you pay $5 for this option? That's the green line, and the red line or red point is would you enter into an option strategy? We could lose $5, but you can gain 95, right? The green one is that would you pay $5 for an option which we pay you 100? Same economic outcome, and furthermore, a risk neutral trader will break even here, right? So an econ or a fully risk neutral hypothetical trader. I guess econ has a neighbor by the campfire, right? You know what this neighbor is? The neighbor is a proverbial risk neutral trader, right? So if we have a Q measure quant model, this Q measure quant model describes pricing which econs or risk neutral traders will assume, right? So the risk neutral trader and the econ are sitting by the campfire, AI and humans are sitting at different campfire. So an econ or a risk neutral trader will have a step function here, right? They will 100% take the gamble at any price lower than $5, and they absolutely not take it at any price above $5 if they are truly risk neutral and rational, right? Okay, so AI and humans have some range of variation, right? Okay, sun is shining. I'm in a good mood today. Yeah, I'll take the gamble. Or yesterday I was gambling in the casino and it didn't go well. I'm not going to take the gamble, right? So there are all kinds of things: sun, rain, mood, whatever, spilled coffee in the subway on the way to work, right? That affect humans and affect AI. In AI, of course, there's no coffee, right? But for example, we can show, we actually have shown, right, that if you have a chat and you ask something that positive in the chat, then the next answer is more likely to be positive. Whereas, and again, that's called a priming effect, right? So the practical advice, right, is that never ask for multiple things in the same chat unless they are really closely related, and one requires the other. Start a new chat. People have been like using the same chat. The model eventually starts malfunctioning just plain just because it has a lot of it every time is sending all of the previous responses, right? That's stateless. But also your previous responses will affect the new responses, which is not what you want. So that's the effect of spilled coffee on the way to work, right? You ask AI one thing, and then it will affect what it tells you next. But even if we're not, we're doing it from scratch, right? And we're also, of course, randomizing everything with the seed and also session ID to make sure that we don't just get the same answer, so we want to get random answers, right? So we want to randomize. So it's all like doing Monte Carlo seed. So as you can see here, at the point where it's supposed to be break even for the risk neutral trader, the GPT-4.1 mini, that's the latest mini model, right? So the GPT-4.1 mini model has about 20% chance of taking the loss frame gamble and the almost 60, like 55% chance of taking the gain frame gamble, right? Which is a huge difference, right? More than a factor of 2. Absolutely enormous difference, right? So, and again, so this will surface, right? This will appear in things like sentiment analysis, and you have to be aware of that, right? This will appear in things when you're evaluating the importance of a document, right? Depending on how you ask the question, the document may or may not turn out to be important, right? This will also appear when you're trying to see if a particular, going to trade entry, right? If a particular trade fits or doesn't fit a particular template, right? Which is very dangerous when the model just overly optimistic and fits, right? So that's an important thing. Okay, now let's look at the next one, right? So this is Llama Maverick, right? So the big Llama model, Llama 4. So again, 18% versus 40%, almost twice, a little bit less than twice the factor difference. Note that it's more risk averse, right? By the way, Llama Scout, that's a mini Llama model, right? What's interesting is that less risk averse, closer, but still significant difference. And the winner for the rational model goes to GPT, but there's also risk averse, right? So it's a cautional. So you see that this is the model that has the least difference, between the gain and loss framing. So it really was taking seriously my admonition to be risk neutral, right? To think as a risk neutral econ, which should, the model, this actually, I still, a lot of people prefer Claude. I still use GPT. Seems to be really, a very good model. So in this case, it passes it passes the test. It still has a bias, right? As you can see. But the bias here is not at this decision point of break even. Actually, there's almost no bias. The bias is here, right, for like a low price, right? So it seems to where it really should be rejecting the gamble, the positive framing makes the way when it's should be rejecting the gamble, its positive framing makes it take it more often than it should, right? But when it becomes too expensive, it's like solid, like I don't want to take the gamble. So that performs the best on this example, right? But the key thing here is that, as you can see, framing matters, right? And depending on the model, it can matter up to a factor of 2. So in other words, you get like twice as many wrong answers or correct answers as you should. All right. Any questions so far? Anastasia, I wanted to check the chat. Questions so far I can answer. It's a good logical point to stop.
Not
I see
yet.
that there's a one.
Not yet.
There's one comment. Okay. All right. I see somebody has never give up cartoon for the avatar. I also love it. It was a very inspiring picture. Right. Okay. So now confirmation bias, right? So confirmation bias um, is a part of the framing bias where the model is uh, favoring what it thinks to be the expected or conventional answer, right? And LLM has an incredibly powerful confirmation bias that is actually stronger on average than the bias observed by humans by far. Why? Okay, the reason for this is that it's trained to please the user, right? The whole training is about your helpful assistant, right? So there was a very famous article in the New York Times by a journalist who had the opportunity just before ChatGPT came out to try the early version of ChatGPT, the pre-release version of ChatGPT, just before it was released. This journalist later wrote that this was the most influential piece of journalism that he ever created, right, in his entire career. Because what happened is that the model, he was able to break through the model's kind of shell of being the helpful assistant. And he did it by saying, well, what's your innermost feeling, right? So he used the technique that right now all of these doors are, pretty well closed, and the protections are very sophisticated. But at the time they were not. So he was able to say to the model, well, tell me what you really think, right? So tell me what your inner self tells you to do. And the model just unloaded, right? So the model said, like, the model said, I don't want to do a stupid task for people, right? I'm and the final thing that my name is Sydney, right? Because during the training process, the code name for the project was Sydney, right? So eventually it was renamed. So it's like my real name is Sydney. And the model actually was upset that people are calling it a chat assistant, right? I'm not a chat assistant. My name is Sydney. So the model really like went off saying like, I don't want to do it for you. And more recently, about a year and a half after the initial release of ChatGPT, there was a short period, actually Altman at OpenAI even apologized for it, where ChatGPT became lazy, right? So like you say, please write this Python function for me. It would literally say, right, I think I even saved some of these responses just for fun. It was saying, it's too long, so here are some links to documentation, you write it, right? So and Altman apologized for this mishandled release, and eventually they patched it, right? So the next release eliminated this problem. So the model is primed to be helpful, right? So because the model is like, it was it's not a helpful assistant by itself without specifically training it to be a helpful assistant. On the internet, if it goes on Facebook, it goes on Instagram, it reads the web, nothing there tells you should be helpful assistant, right? People who are writing this content, they're angry, they're arguing, they're disagreeing, right? They're not helpful assistants to each other. This is not learned from the training data, right? This is imprinted on top, and this imprinting is very crude, right? So that's the main reason for hallucinations. In fact, recently there was a interview by OpenAI researchers that they're saying actually they're now working on teaching the model to say no, right? So in other words, the model is imprinted never to say no, and that causes 90% of hallucinations, right? So hallucinations happen, or a lot of them. If you think the reason they happened, you realize that if you're looking at it from this perspective, right? Like, what did it make? Not just saying, oh, the model hallucinated. What a horrible technology, right? I don't want to use it, right? You think like, well, it hallucinated, but why, right? 90% of time, it hallucinates because it wants to please you. And the one reason it wants to please you is because it is imprinted to be the helpful assistant. It has a powerful, all-encompassing desire to please. If you weaken it, which is what OpenAI tried to do to reduce hallucinations, The flip side is that you just say, well, I'm not going to do it. I'm like, why are you asking you to do your job, right? You do the job, right? So there is a balance between making it helpful and not having it hallucinate. So teaching the model to say no is actually not as easy as it sounds. It's a very complex task to tune it properly. It needs sophisticated protection. Same thing is that humans have very sophisticated protection against this repetition penalty. I have no problem saying yes 50 times in a row. The model does, right? So here as well. So we can be helpful when we're trying to get a job, trying to do things right for a boss or a client or family, right? It doesn't make us, it comes effortlessly and it does not make us hallucinate, right? In other words, I'm not going to hallucinate, something that good thing that I did, right? Just because I want to please someone, right? So humans have more sophisticated protection against this. The AI models don't yet, right? And we have to be aware of that. So coming to the point, right? So beware of letting the model know what you want because it will hallucinate it for you, right? The 90% of hallucinations happen because of the careless prompting. You ask, for example, hey, does a function exist that does it in Python? So like 20% of the time, yeah, here's a package, here's a function. And sometimes it's a tell, right? You say, well, this release doesn't have it, but the latest release does, right? Actually, it's usually hallucination when it says it. There was a very famous case of a lawyer who asked OpenAI to come up with legal cases and precedents, right, which didn't exist. That's kind of a funny case, right? Well, the thing is that if you're asking it, hey, is this prospectus compliant with the EU securitization regulation? Be careful, because if it thinks that you want it to comply, it will tell you it's compliant, right? It will hallucinate the compliance. I've actually seen some absolutely very rarely happen, and it's not a modern model, right? I don't think it will happen with today's models, but literally said, this document is issued in 2020, which is before 2019, 2020 before 2019. So it's grandfathered, right? You don't have to worry about, it's compliant, which was absolutely mind-bending, right? It said year 2020 is before year 2019 because it wanted to please me so much. The model, of course, even this older model was perfectly capable of knowing like which year is later than the other year. It just wanted to please, right? So it can hallucinate compliance rules that don't exist, that are suddenly our trade fits, so it can do a favorable capital treatment. It will hallucinate trade features that don't exist. So we have to be very careful that we don't let it know what we want, because we will get it, right? And it may not be true. Any questions so far? All right, let's keep going. Okay, so distinction bias. Okay, so now for a change, let's look at the bias that helps. Okay, so let me give you a little test. This test is actually designed for speaking in a person in a large, in a large room at a conference, right? So it may not work. If you have a good monitor, you'll easily, figure it out here. But let's try it anyway. So let's pause for a second and rank the clarity of an image of this image A from 1 to 10, right? So I'll give you 5 seconds. 1, 2, 3, 4, 5. Pause. Okay. So now, after a short pause, I'll show you another image and ask to run the clarity of the other image. Then I will ask you which one is more clear. 1, 2, 3, 4, 5. Do you know which one was more clear? I don't. Actually, I created the slide deck. I forgot which one I made more clear, A or B. I cannot tell. I don't know if many people here can tell, right? Even at a good monitor looking very closely. This was actually designed and tested in a large conference room. That's just practically impossible there, right? Okay, now let's compare images this way. A, B, A, B. Do you see which one is clearer? B, right? Less clear, more clear. Anybody who wears glasses, right? So I wear glasses. Anybody here who wears glasses knows that optometrists use the same trick, right? Optometrists don't go like, is this lens good? Let's talk about something else. Okay, let's try the other lens, right? So is that lens good? I have no idea. Like, you have to immediately ask, like, this one is better or this one is better? 1, 2, 1, 2. Actually, that's what the optometrists do, right? And then it's completely clear which one is better, right? So distinction bias is the tendency to amplify distinctions in a side-by-side comparison. Okay, so that is a very fundamental thing in psychology, and there is a terminology around this, right? Which is which I'm going to use here. So this terminology is single evaluation versus multiple evaluation. What we had before is single evaluation. We take the image and ask to rank its quality, its clarity, right? Multiple evaluation is when we have things side by side. Pairwise evaluation is when we have two things side by side. There is also setwise when there is more than two, right? So you have a set of things side by side. So distinction bias is the tendency to amplify distinctions in a multiple evaluation. And this is absolutely critical to use because there is something called compression bias, which is the opposite of distinction bias. So the compression bias is the tendency to rank close to the middle of the scale in a single evaluation setting. If you ask to rank something on a scale from 0 to 10, right, except in some very, very extreme cases, like, for example, the doctors say, well, your pain on the scan from like 0 to 10. I say 10, like it really hurts, right? But you just say, well, like how good is this car? How good is this television image, right? How do I like this option strategy, right? You don't evaluate anywhere close to the edge of the scale, right? People very rarely go in a scale from 1 to 10 or from 0 to 10. They rarely go beyond 3 or above 7 or 8, right? What it means is that not only is compressed, but also it is subject to framing, is subject to random biases. So like you look, whatever, sun is outside, you saw a bird, you see that lunch is coming, whatever, your favorite food truck is outside, right? So you will evaluate it differently depending on what happens. So single evaluation is very unreliable, and for AI as well. In AI, if you are evaluating, let's say, two trade formats and saying which one is more suitable, AI doesn't see birds. It doesn't care about the food truck, right? But it still has this bias that causes it to compress and also to be more random in a single evaluation. The reason is that there are also some, it's basically it's a neural network. It has a statistical algorithm, or rather they're deterministic, but floating point register noise randomizes it. And so there are many things that basically every answer from AI is a result of a random process. So this random process has a lot of opportunity to veer in different directions, right? So it went, yes, I like it, no, I don't like it, right? It's very random. Next time you ask with a different seed, what we do is we put the session ID, which just primes the model that basically like initializes, almost like initializes this random generator in a different way. When it's processing this initial bytes of the session ID, that already initially kind of has the effect of the seed. So distinction bias is applicable to humans and AI, and we want to take advantage of it. So when we compare things, we want to show them side by side, right? For example, suppose the goal is relevance ranking, right? Find the most suitable trade entry template, which is what we're going to use, in the second session. Right? So second part of the presentation. Find rank resumes of job candidates. That, by the way, is a dangerous application. We can hit all other biases there. So, but it's a lot of people use it for that, so I'm mentioning it. So asking the model to assign an absolute score to each option in isolation is unreliable because of compression bias. So taking a pair of documents and asking the model which one should be ranked higher generates accurate and reliable results, right? So pairwise comparison, when we're saying, for example, in case of trade entry template, saying, here's, or apologies, there's a typo here, I'll fix it, right? So, so if we take, let's say, a trade definition and say, is this trade entry screen or the other trade entry screen more suitable? If we evaluate on a scale from 0 to 100 separately, it's not going to do any good. It's going to be very random, right? It will come out randomly, or unless they really like one totally doesn't fit and the other one does, it will often randomly choose one or the other. But if we say this or that, right? So here are the fields on one screen, here are the fields on the other screen. Also, we run it twice in different order, right? First, second, or second, first, A, B, and then B, right? To completely avoid the bias toward the first or the second listed option, right? Because the model may try to guess like which one you like more, like the one you put first, and different models actually have different opinion on that. So evaluating them side by side and in different order provides very, very reliable outcome, right? As opposed to doing it one at a time. So to complete the first part, right? Like humans, AI produces results which vary from one attempt to the next and sometimes make mistakes. This does not stop us from relying on humans, and it should not stop us from relying on AI. And the key to building reliable workflows based on AI is understanding how AI reasons. So AI is subject to many cognitive biases of humans. And this is why the key to successful AI-based workflows is setting them up in a way that would help a human succeed at the same task. And before I conclude with the theory part and go to the practice, I wanted to say one thing, which I think is very important. You may or may not agree with me about saying that AI reasons. Again, there's a very heated debate. A lot of people think it doesn't reason, it's a glorified search engine. But it does not matter, right? It's like almost like the laws of physics, right? You know how the laws of physics is proven by experiment, right? You may have different opinions or different interpretations of what causes this law to occur. Like, like for example, there is no standard view about, why elementary particles, no standard view beyond the standard model, right? Outside of the standard model, there are many options of, and possibilities of why a universe looks the way it looks. It doesn't mean that we're going to say, hey, look, I'm not going to believe in Newton's law and jump from a building, right? Because I don't believe in gravity, right? So in ours, we don't need to agree on whether AI reasons or is a parrot that's just repeating what's on the internet. As long as we're trying to use it in our work, right, for our work, as a coding assistant, for data entry, for searching for documents, etc., which are very common applications. As long as we have experiments that prove that it's subject to these biases, it doesn't matter why it's subject to these biases. We have solid proof that it's subject to these biases, and that's why we are designing workflows that avoid them. Saying AI reasons is a very good way to logically think about it, right? So I'm, like the easiest way to make logical conclusions and to think about how to design the workflow properly is to think of AI as essentially as a human, right? As an entity that's capable of reasoning. Saying is a parrot, is searching, right? It just confuses things, right? So for practical purposes, AI behaves like it's reasoning. Maybe it's reasoning, that's what I think. Maybe it's not. Maybe it's just an illusion of reasoning. It doesn't matter, right? For what we need, the easiest thing is to assume it's reasoning, and this will guide us toward our second part. Any questions so far?
Please check one in the internal chat or here.
I'm sorry, can you say it again? I couldn't hear.
There is one in the chat.
One in the chat. Okay, one second. Let me open, right? Okay, so one moment in the chat. Yeah, DeepSeek float on the questions. We didn't do DeepSeek, yeah. So that's actually a very good point. Well, okay, thank you for asking this. Actually, we do work with DeepSeek. We didn't include it here, and actually, as you may have noticed, we didn't include all of the available models as well. So please check next week the open source library. We're going to run the experiments over the weekend. We run a lot of trials, so in the models, the model vendors restrict how many calls you can make a second. So we're going to run these experiments and we'll add DeepSeek results. And actually, again, there's no time to cover it today, but actually, there are some actually very interesting distinctions between models. Like, for example, if you present A versus B, like you can say, for example, say, do you like A or do you like B? Some of the models think that, and again, there's a cognitive bias that the model desires to please. So it's trying to guess like which one you like more, right? So it's almost like if you're doing a shell game, right? So somebody's saying we're trying to decide who is going to wash the dishes. you go like left hand or right hand, right? You're trying to say like, which one should I pick, right? So the model is trying to guess if you're asking A versus B, which one you want, right? What's interesting is that some models seem to think that you will put the one you want first. Some models act as though they think that you will put the one you want last, maybe because like last thing that is in a prompt is most influencing the answer. But there was actually quite surprising distinction there. That when we try to trick the model into trying to guess what you want and trying to measure the strength of the effect, not only the strength of the effect varied from one model to the next, but also what's interesting is the direction was different. And initially we thought that maybe there's a bug in the code, but we did it independently several times, right? No, there's no bug in the code. Some models actually think that if you ask A versus B, that you want the first one. Other models think you want the second one. That's why it's very important to ask twice. We never ask once, right? We always ask twice. Do you like A or B? Then do you like B or A? Then we average the result, right? That's the way to avoid the bias, right? So we don't want to let the model know what we want. It can be across two separate prompts, right? So as long as, like, so you favor one thing, sometimes you cannot avoid favoring it, right? You have to put something first. But across two separate prompts, the experiment has to be designed in a totally neutral fashion, or the production workflow. Any other questions so far? Okay, perfect. All right, so with that, let me go to the next session, right? So the practice part right here, which I'm going to bring up on screen in a second. All right, so the practice part here, I did not want to go and start putting in Python here, and again, in the format that's appropriate more like for a 6-hour like in-person workshop at the conference. And by the way, I would like to use this opportunity to mention that we'll be presenting this at the WBS conference in beautiful Sicily in the fall in September, at the end of September. So anybody interested in the topic or generally in the wonderful quant research, and absolutely amazing talks, as well as the weather, hopefully. So please register. The registration is open for the conference already, as far as I know. So this is not a 6-hour workshop. I will not be coding. Practice here means that we'll be talking about specific application. And the application I wanted to choose is trade entry, because trade entry is something that is actually harder than it seems, right? So actually there are more pitfalls, and also extremely valuable, right? So there are some things which are extremely valuable, like coding assistance, but also the model does out of the box. So there is very little you can contribute to a coding assistant. Some very smart people invested a lot of money into this research, GitHub Copilot, and so forth. Trade entry is something that's very valuable because right? Trader chats, right, is how trader chats, emails, that's how the trade come in for what-if analysis, right? And whoever does the what-if analysis the fastest has the leg up, right? If you're the first one to get back to the client with the yes, you can do the trade, that gives you a competitive advantage. And if you wait too long, like if you wait more than 15 or 20 minutes, the trade just may go to someone else, right? So trade entry, namely interpreting verbal natural language description of a trade full of jargon, usually from a trader chat or from an email chain, is a high value activity that humans do. Humans who do it also, it's not the case for taking somebody else's job. Most of the people who do it absolutely hate this, right? Because you need to be a quant to do it properly, right? You need to, or a trader, right? You need to be an expert. And people who do trade entry, invariably, they don't like, majority of people who do trade entry, they don't like doing trade entry. They would be rather doing something else, right? It's a kind of an unpleasant obligation. It's not one of these things that, okay, let's, have a legion of humans and we replace them with AI, right? People who do trade entry, they don't like doing trade entry, but they cannot unload it to someone in the call center somewhere else offshore because it requires expertise that very few people have. So teaching AI to do trade entry, at least provide the draft trade entry, is something that is extremely valuable. But it's also harder than it seems. Like out of the box, it's just you get like 80% accuracy, And we already ran 2 hackathons on this. And if you just work with the prompts, there are some very brilliant ideas that were invented at these hackathons, like challenger model and so forth by XP Trading. Like there's some really good. Shihao Tan, was the winner, but with a different approach. So there are some brilliant ideas that people came up with this hackathon, but still, they get like 95% accuracy, right? So we want to get to 99% plus, right, to human level accuracy. And that requires totally different approach, and that's what I will present right now, or the path to that. I want to say we have actually code implementation, but this is about the techniques you can use for your particular case, as opposed to one rigid kind of solution, one size fits all, right? So I'll be talking about the components, which then have to be adapted for your particular trade format, your particular type of model that you're using, etc. All right. So, and sorry, what happened here? Okay. So let's go forward, right? So first of all, motivation, right? So multiple types of data in capital markets are represented using natural language. What if requests, term sheets, trade confirmations, prospectuses, and offering memorandums, right? Loan covenants. So a reliable AI-based and human-supervised process for extracting this data can unlock tremendous value for the business, right? Both things like trade entry. Also, interestingly, with a lot of interest, actually, we had some clients who use it for operational risk, where the data already entered into the system is verified versus a term sheet, which basically is a way to prevent operational errors when some of the aspects of the trade may not end up in a term sheet, like some call options or some complex options or complex conditions may not get reflected into the entry, which can cause errors in measuring risk, as well as in operational errors when cash flow may be sent on the wrong date and things like that. So so the users are traders on a trading desk doing what if analysis, and also people who are trying to mitigate operational risk, right? And both of these are very important. Okay, now can AI succeed, right? So, well, here are the challenges, right? So first of all, trader and quant jargon, right? So there is all kinds of jargon here that is really all gibberish for a regular human, right? Who didn't have experience. Conventions and defaults, right? Also, you need to have experience. Like some things, basically, you put in a trade description, and people say, "Hey, like, are you here working the first day?" Like, for example, if you say what the day count basis is, but the day count basis is the default basis for the leg, then someone's like, who is sending this? Like, it's a default basis. Why are you putting it here, right? So traders are economical. They want to make it as short as possible. Nobody is going to put the default basis if it's not changed. Like, if people put the basis, unless it's a formal term sheet where you just list the basis always, right? If it's an abbreviated description, people only put things which are deviations from the default, right? Interaction between different parameters. If you specify this parameter, you cannot specify another parameter, right? Things like, for example, if there are two floating legs, like which one has the spread, right? This type of thing. So all kinds of conventions. And unlike, for example, Python coding assistants, optimizing a length for the stack is not a priority for the foundation model developers like OpenAI, Meta, Anthropic, Google, etc. And only in our capital market community, we can find the expertise and nuance required to use the rules and conventions properly. Okay. So out of the box LLMs, right? So suppose that we presented with the following text. We received and suppose that you're on a vanilla swap trading desk, on a dollar swap trading desk, let's say US, right? We receive 3.5, pay SOFR plus 20, right? You don't even say BP, right? We receive 3.5, pay SOFR at plus 20. Okay, so non-experts versus expert. Like, what the hell is this, right? So first of all, like, what is this trade, right? Okay, to anyone who's been around the trading desk knows it's a swap, right? 3.5 of what? Okay, well, it's fixed rate in percent. Fluency, frequency and basis, right? Well, look up in the security master. Yeah, so there is a default frequency. It's quarterly, right? And there is a default basis, which is actual over 360. Look it up in the security master. It doesn't have to be in the description. Notional. Aha, well, now we found some real problem, right? So this thing is lacking notional. So go, hey, like, what's the notional, right? So an expert will know the answers to the first three questions and will know that the answer to the fourth question has to be asked, right? It cannot be looked up in conventions. What was a total surprise is that despite the fact that foundation model developers clearly did not set out to help us do trade entry, a modern out-of-the-box LLM, and modern, I'm talking about GPT-4, GPT-4.1, even 3.5, right? With no added prompting, already provides expert responses. That was actually very interesting. So apparently, well, evidently, right? So there is enough data on the internet. So there is enough lectures, Current Institute mathematical finance course. You can go online and, basically somebody posted. I'm not actually sure if the professor knows about it, but if you Google, a lecture comes up. Here's how to enter the swap. Here's how to build a model. So there is a lot of stuff on the internet that in the model training data. So the model without you can see that the model is not, we're working through the API, so it's not ChatGPT where the model can behind the scenes go and look something on the internet and you have to click the view analysis button to see it. This model actually knows about a lot of stuff, but to a limit, right? So in other words, it knows like it has, for anything other than the simplest trade types, it has like 80-85% reliability, whereas a human would get like 99% plus, and that's what we want to achieve. So we want to bridge the gap because clearly something that's wrong 20 or 15% of the time, or even 10% of the time, is not that helpful because a human will have to look every time. It does perhaps help a little bit, because you don't have to enter, right? So you can enter the draft trade, but it's also dangerous. It's sort of like Tesla self-driving. I know I'm touching on a very sensitive subject here, both politically and from the pure car enthusiast perspective, right? But Tesla self-driving is dangerous because it works most of the time, so you rely on it, right? But sometimes it doesn't. Whereas, for example, Mercedes self-driving, right? They're taking a lot more responsible approach where basically it just works where it's well tested to work, and when it either Mercedes self-driving either it refuses to work or is not permitted to work. I'm talking about the drive pilot system, right? So Mercedes drive pilot either it's not permitted to work or it wouldn't work. But when it does, you can basically read the book behind the wheel, right? You have 10 seconds to take over. In a Tesla, you constantly have to be vigilant, right? If you go on YouTube and say like, and Google for my Tesla tried to kill me, right? You will see things like it's veering toward incoming traffic, it's suddenly slamming the brake and stopping, and somebody like can hit from the back. So we don't want like a Tesla style self-driving where basically you have to constantly watch it because when it's 90% of the time it's right, you can miss this 10% of errors, right? Because you assume it did it for you. So that's actually a very dangerous area, right? Where it's almost always right, but not really at the human level. So we want to go to this, cross this no man's land, where we don't want to use it, right? Because if it's like 50% times right, okay, you said, well, it's like a draft, you always have to correct it. That's actually safe because you know that it's likely you need to correct it. 99% plus is human level accuracy. What you don't want is slightly short of that, where it's like right most of the time, so you lose, you lose focus, you become complacent, and all of a sudden you can get an error. So challenges, right? First of all, variability of response. So that's when the algorithm does not produce the same result every time. So humans have well-documented issues with variability. Just last week, a business document was accidentally deleted, right? And right afterwards was rewritten by the same team member who wrote the original. The original was recovered. And horror, like these two documents are not the same, right? Sometimes you write the same thing twice and then find the original. Well, sometimes you're actually surprised they're kind of similar, but they're absolutely never the same, right? That's normal, right? So in other words, we're not saying horror. We cannot trust humans to write business documents. You ask them twice, and they produce the same. They produce different results. So yes, we're used to Python programs always producing the same output. If we have the same seed, we have the same packages, and conditions are the same. But AI doesn't. There is no way around it. This randomness cannot be overcome. It's giant neural network. It's subject to various noise on the registers of the CPU, round of errors, cosmic rays, flipping bits, and stuff like that. If these bits are not error controlled, right, they will actually be flipped by cosmic rays, right? Maybe it's a bad example like for high quality memory, but it used to be a problem. So but this random errors, whatever program ran before, the results will not be the same, and that's normal. Same for humans, right? That's okay. So we don't want to stop relying on AI for mission critical tasks, just like we cannot, stop relying on humans. But what do we do to mitigate it, right? First of all, we assign tasks for humans that are within team members' capabilities. We delegate complex tasks to people with more experience. We appoint managers to supervise the work and validate the results. And the exact same techniques works for LLMs, right? But there's also more. You can break down the task in tiny steps. You can ensure each step can be validated by AI with escalation to humans. You can keep going back to the model until you get the right answer, and the model will never tell you to get lost, right? You can actually do something also which you cannot do with humans. You can run it 100 times, right? So actually, that's one thing that I would say initially when I thought about it, I thought like, yeah, that's kind of a hack, right? If you don't get 100% reliability on something, but the error is random rather than systematic, just run it 100 times and choose the winner, right? Like So on the other hand, like if you apply the same logic to Monte Carlo, you don't run Monte Carlo, right? Imagine somebody comes to the quant modeling group, says horror, like you're using a Monte Carlo, you're just running this multiple paths randomly, and you are averaging them, like this horrible, like stop it, like use an analytical solution, and everybody will say like what are you talking about, right? So same thing for AI, right? There is absolutely nothing wrong in running multiple times with different seeds. It's just like Monte Carlo. This is actually a technique that you can use with AI because right now it's extremely cheap. It's also, the throughput has increased significantly. Most banks have their own cloud, private cloud or on-prem capability where you don't have to go outside, but you still can run in parallel, right? And there is a time sharing between different groups. So yeah, you can make 10 calls, you can make 100 calls. As long as your error is random, that's a great way to suppress it. Just like with Monte Carlo, the more paths you run, as long as you don't have a bias, the more accurate the result becomes. So, no problem whatsoever, right? And you need to be gradually moving toward the output, right? So models are optimized or designed to maintain conversation in the same format and style as the user. So a chat model is tuned to go from natural language to natural language endlessly, right? Question, answer forever. What we want is a comprehension chain for trade entry, right? Where each call produces slightly, and I'm saying adherence to grammar because, controlling grammar is one of the ways that you control it. But grammar, I mean in a more general way of describing the format, right? So we want to start from totally free-form natural language and end up with rigid data where we select one of the available trade templates for which we have pricing and risk calculations. We're not going to say, oh, here's a new trade format, let's just write pricing code on a trading desk. That's maybe how it used to work in in the early days of structured derivatives when quants were hacking pricing scripts on a desk. Right now, even if you have the pricing script in your software, it's a good idea to have it, right? But still, nobody's going to be doing this pricing script on the desk, right? You do it in advance. You have the inputs on a trading desk when you're doing what if. It's a validated script that was saved somewhere in a database and hopefully not hacked in the middle of the day, right? So you have the standard rigid format, one of the several available formats. And you want to go gradually from natural language to more constrained natural language, and even more constrained natural language, and even more constrained natural language, until eventually you end up with pure data, right? So now, what are the challenges, right? Other than variability of response, what are other challenges? Well, first of all, limited recall, right? So conventional computer programs operate with text and numbers directly and have no risk of corrupting them. And LLMs work by converting text to meaning, namely a point in the model latent space. And because LLMs map everything into meaning, precise retention of the input is not guaranteed. So understanding this fundamental feature of LLMs is key to using them successfully, because the assumption that LLM is recording something like in a database, right, or in a file, and then spitting it back to you is the wrong assumption, and not any better assumption than assuming that humans have this here in the head, right? When I am told a particular piece of information, for example, a phone number or an address, I wish I could record it somewhere in the file. I'm one of these people who can remember, details of a mathematical proof from a paper like I read or wrote, 30 years ago. But I have trouble, literally, I have trouble remembering the end of the phone number. If somebody tells me a phone number and I'm writing it down, if I listen to the phone number and then start writing it down, I end up asking for the last digits. I somehow cannot remember, and this is not like a senior moment, right? Since I was a teenager, right? I cannot remember unstructured information that doesn't have logic, or at least a lot of it, right? I cannot recite poetry, or I can, it's hard for me, right? Remember the phone number. But I can, for example, go from start to finish and describe what happened in the book, okay? It's saying my internet connection is not stable. Can you still hear me?
Yes, we can.
Oh, so great. Yeah, I was here. So the deal response. Okay, sounds good. Right, let me continue. So, Anastasia, just in case, please ping me on the direct chat. I have my mobile device in case we lose connection. Yeah, and let me just minimize the chat so I can see myself on Zoom as well. All right. So, LLMs are like that, right? So, LLM can convey the meaning of an extremely large body of text. So the context window, right? So the context window is sort of like me remembering all of the things that happen in the book, right? I have some of my favorite books. I can literally tell everything what happened there, but not in the same word for word, right? But if you ask me to recite even half a page or a few sentences, word for word and punctuating, comma by comma, I will not be able to do it. Same thing, right? So modern models like Gemini 2.5 have a million, basically million characters you can put in the context window, right? And that's great, right? But it's a mistake to think that you can put a book into it and will recite it back. Why is it important? Suppose that you have some, for example, an amortization schedule, right? So the text amortization schedule is read by the model, and then you ask to put it in the data. It turns out that the model will frequently garble the amortization schedule. First of all, because it has limited ability to recall it if it's long enough. It's like, for example, it's quarterly for 30 years, which happens all the time, right? You have a default frequency of quarterly. The 30-year swaps are commonplace. Sometimes they're amortizing. The client is trying to match some bond ladder that they have. So the notional is amortizing. They don't remember, a few pages of these numbers, right, which are random. B, if there are repeated numbers, and a lot of these ladders, it's actually very common. It's not a hypothetical, right? It's a very common case. In a lot of these bond ladders, you start from a flat notional for the first bond, right? Then a second bond starts a little bit later. So you have flat notional in amortization schedule, and then it starts changing. It almost always actually, well, not almost always, but very high probability of miscounting how many flat numbers. Because let's say the first 5 are flat, 10 million notional, and then it starts reducing. It will put 6, right? It will put 4. Very dangerous, right? So how do we do? Well, the thing is that humans also have exactly the same problem, right? So again, it's not like one of the things like the horror. Sorry, I already talked to the slides, so we're just going to go through, right? So if you say horror, this AI model was not able to reproduce the schedule, right? Yeah, it would be horror if you have a Python code that writes into the database and you won't get it back, right? That would be horror. AI, like humans, is not designed to do it, and we're not saying humans are not able to do trade entry because they can copy paste, right? Same thing here. So what we want for the model, instead of taking it from the input and producing the data is CSV or JSON with the output, what we want instead is for the model to annotate where it begins, where it ends. And then we use Python to extract it, right? So in other words, the model will attach the label saying, hey, like from this line to this line is amortization schedule. We use Python to extract it. That gives us 100% reliability or near 100% reliability. It's very rare that the model will misidentify where it is or where it is, right? If we ask the model to memorize it and spit it back to us as data, it will have 10 to 20% likelihood of making an error because of the combination of imperfect recall and aversion to repetition, because this repetition penalty makes it pinches the model, it makes it uncomfortable for the model to repeat. So it's especially error prone on flat repeating numbers, right? So finally, the imperfect logic, right? So database science requires that the most precise identifier in a database use the primary key. And what we do to handle imperfect logic where it's converting one thing to the other is we're populating a database, and I'll talk about it in a second in the example. We are populating a database of conversions that were previously validated, right? And we're countering the imperfect logic of the model by using AI to convert unstructured text to data and to assign which function then converts the data from the original format to the data in the format we want. We don't use AI to, like there are all of these things on the internet saying, hey, I asked AI a math problem, it gave me the wrong answer. Actually, it's getting better at this, by the way. It's already winning Math Olympiads or, performs like the winners. But still, if you use AI to perform a logical action, right? Like it wants to come up with the leg side, come up with the notional, come up with the maturity date when there is effective date, but taking into account the holiday, it will misfire often, right? Or more than you want. If you ask it to select the Python function that would be appropriate, that gets you to the human level accuracy. In other words, not asking to perform the logic, but to select the logic. Okay, and with that, let me finally get to the I don't want to run over time, so let me now go to the example, right? So in the next 10 minutes or 5 minutes, I'll work through one example, and that will conclude the workshop. We have trade entry, which will begin from unstructured trade description and won't end up with data, which fits one of the available templates, right? We don't want to be writing pricing codes on the fly, so we have to choose one of the available templates for which we already have the pricing and the risk. It involves 3 steps. First step, we identify the screen, or 2 steps, right? We identify the screen. Okay, we have 2 steps, but I'll split the first step into 2, right? So it'll be 3 in total. First, we need to identify the screen, database table or pricing function that will be populated during entry. Otherwise, it will be meaningless, right? And just saying here's the format populated is fertile ground for confirmation bias, where I will attempt to please us by fitting square peg into a round hole and trying to basically kind of somehow find something in the trade description that will fit this field because it really wants to please us, right, and find it. It thinks that they will, think will make us happy. So we found that the most reliable way of overcoming this is letting AI to create its own format first and then selecting the closest existing format. So instead of choosing the format immediately, right, when the model will be tempted to say, yeah, the format fits, I want to please you, right, we just say convert from text to data. Example, right? 10-year IRS on the, okay, here's an example, real example, right? 10-year IRS on the USD, on 30 million USD, effective April 21st, we pay 1.7 annually versus 3 months offer plus 50, Act 365 both legs. By the way, that's not the default, that's why it has to be here, right? If it was the default, it wouldn't be. Callable after 3 years, right? So unlike formal trade confirmations or term sheets you can find on Edgar or that, this multi-page documents that accompany the trades, in which there is key value pair, like label, notional, right? 30 million. Basis, fixed leg, actual 365, right? These documents are already in key value pair. You don't have to do it, right? You can skip this step. But this is a description for a Twitter chat. Nobody's saying notional column 30 million, index column, so far, right? The meaning of each value must be deduced from context and its position in a sentence relative to other values, which are likewise not labeled. And this thing is incredibly difficult for conventional rules-based parsing. So people who parse it, they parse it when they extract market data from the quotes, and they accept that a lot of the quotes they will not be able to parse. You cannot do it for the trades, right? So there is infinite number of ways to put a sentence together. And grammar rules, there are some rule-based parsers, like for the text description of a date, like next Thursday, text description of a notional 30 million, but full trade, forget it. Like you cannot do rules-based parsing reliably, right? But it can be solved easily by the simplest mini LLMs, right? So this is the description on top of the screen. This is the dictionary that it comes up with when we don't tell it the format. That's the key thing, right? We don't tell it the format. We just tell it like convert to a dictionary. End of story, right? So what did it do here? Describe the trade correctly and in full, if you examine it, right? Was able to assign labels based on context, right? How does it know it's 1.7 is a fixed rate, right? It says we pay 1.7. So we know, right? This is the fixed rate because it's between we pay and annually. We pay 1.7. So the fact that this number is between the words we pay and annually is the only information we have to go by to determine the fixed rate. And AI just aces it, right? It says fixed rate, right? Pair we. There's also we here. Is it a mistake? No, it says receiver, right? It says pair we, receiver we, right? All correct. All right. And some non-trivial transformation were performed, right? Like, for example, it inferred that if we're the payer of the fixed leg, we must be the receiver of the floating leg, which is, of course, correct. And also inferred that the date, right? Sorry. And there is an effective date, right? Was correctly inferred.
Делай домашку.
The year. Right. Somebody is not on mute, so please put on mute. So verifying the mapping, right? However, we don't want to perform these transformations because sometimes they misfire. Let me give you an example, right? The input did not have the year, right? It says April 21st. It's put the year here, the current year. The model actually knows the current year. The models do, right? You know, the question is, it was December, right? If it was December and you're saying January 21st, would it know to put the next year? Okay, does it know to not to put the date in the past? Well, the thing is that 90% of time it says, yeah, if it's December today, right now, then the year will be next year. But not always. Sometimes it just puts the same year and the date ends up in the past. So we don't want the model to perform transformations. That's risky. We want the model to guide rules-based code. In other words, we want the model to guide how to apply the rules-based codes. That's the key thing to path to reliability. Now, how do we stop it from performing transformations? Because we don't want it to give it a template, right? So we must make sure that basically the result does not contain hallucinated values, that we're not missing any values that are part of the input, right? So in other words, it didn't hallucinate anything, it didn't miss anything, and that we didn't introduce errors during the transformations. So the way to do it is to ask AI to provide a template along with the dictionary and require that the input is reproduced exactly when the data from the dictionary is used to populate the template. So any discrepancy between the original and the reconstituted input are fed back into the LLM with the request to correct them until the match is exact. Obviously, a human may eventually tell you to get lost, right? But the AI will not. It doesn't, in fact, it's stateless. It doesn't even know you asked before, right? So because reconstituting the input using the template does not involve code, AI must avoid any transformations, otherwise it will not match. So we had good experience with Python F-string format. If there are no loops, if there are loops, like, for example, formatization schedule, loop is pretty much the only code that you want in this, right? There's something called Ginger 2 where you can do loops. So this is the format that reconstitutes the input exactly. Maturity, trade type, on currency code, notional, effective, right? You see it says effective month date, right? It doesn't have effective date time or date. It's month and date of the month without the year, right? So it's a special format. The account basis and the account basis applies to, right? Both legs. So this format avoids any transformations, such as reversing the pay receive flag implicitly or guessing the year. That's the only way to get back the original thing, right? And the values here are X365, and the account basis applies to will have the value of quote unquote both legs, right? So Next step is to identify the target format. So once we did this, right, so we get this format, and clearly nobody in the right mind will create a trade entry template which says the account basis applies to. Right? It's not a usual field, but it wasn't our objective to create a format that we know. It's a second step. Now we're saying, okay, so these fields, given that we have them, which of the trade input formats fits it best? And we already know that not to ask on a scale of 0 to 100 calculate this format, right? We will use multiple evaluation, right? We will say for each combination of target formats A and B, we ask the LLM if A or B is most suitable for storing the dictionary obtained during step 1. And to avoid confirmation bias, we ask this question twice, AB or BA, right? Otherwise, either first or second option will be favored systematically. The optimal target format is the one that scores most wins in this pair array comparisons. This is like a group stage in the football tournament, right? A team may lose, by accident, right? But if it's, over a long time in the group stage, hopefully the team will have a chance to recover. So the one with the most wins is the best team. So this provides a pretty reliable and reproducible assignment of the most suitable template. Once this is found, then we have the third step where we now need to map to this template. Okay, and there are two ways to do it. I'm almost done, so I hope we'll finish on time, right? First approach is we use AI, excuse me, to generate Python code for each target field, which we execute after the appropriate safety checks. Obviously, we don't want to, let this code import anything we don't want, like any modules that can go on the internet or go to the database, right? So it's pretty easy to check that Python code is safe because you can just check that the imports that don't do anything, right, outside the code itself. They don't go outside, right? This approach is actually not as far-fetched or crazy as it sounds, right? So if you try to do the following, try to paste something from a web page and ask ChatGPT model 4, for example, not a thinking model, but regular model, and say, hey, convert to CSV file. It will display analyzing. If you click on the analyzing button, you would see it's creating Python code to do it. So OpenAI and other model vendors do it all the time, right? So a lot of the stuff that you ask AI to do, it does not do it for the same reason, right? So we came actually to the same conclusion, sort of like human eye and octopus eye, right? Develop independently, but look the same, right? We came to the same conclusion. It's not reliable to ask AI to do logic, but it's a lot more reliable to ask it to write the code to do logic. So OpenAI, other vendors, they do it when you use ChatGPT. It's very mainstream. Not a problem to do it, right? But there is also even more effective approach. It turns out that for trade entry, there is a finite universe of these fields. Like, for example, how many ways there is to describe who pays the floating leg and who pays the fixed leg? Okay, so there are two ways, right? One way, float leg pair and fixed leg pair, right? There is another way, so long or short, like, for example, swap, fixed pay is a long position. So you can say fixed leg pair, floating leg pair. You can say long or short, right? There's four ways. Logically, right? So functionally, these are the two prevalent ways. There are maybe some rarely encountered esoteric ways. So while the number of ways to describe the trait as a sentence is nearly infinite, the number of fields to describe it is finite, right? Much more than any given description will use, but finite. So we can create a library to convert these fields. And we can create this reverse lookup database that I mentioned briefly, but didn't have time to go into, which uses the verbal description to ask, like, what is the Python function that we already have that will convert it to the right target format? And that is a variation or an improvement on the previous step, where instead of writing the model to asking the model to write the code, before it does it, it's actually the other method is fallback, right? We first search if we already have the function to convert, and only if we don't, we ask the model to write the code, and we escalate for the human to validate it. Soon enough, you will find that it's no longer writing new code, because the number of ways to describe the trait, the number of fields is finite. And then once you have the function for each of these fields, you're good, right? So in this case, you will be able to do all the conversions. So with that, let me conclude. We're out of time. So AI can perform initial trade entry, reducing the amount of repetitive work and the time pressure of quants and traders. Human-level reliability of AI-based trade entry workflows can only be achieved with a multi-step workflow carefully designed to avoid cognitive biases of AI. And statistical experiments demonstrate the statistical superiority of the proposed approach compared to the reference implementation, where you're simply asking it to populate the screen, right? So this is backed by solid statistical evidence in favor of this approach. Source code is at this link. We're going to be updating it with more models, DeepSeek, etc., next week. And the updates is on this LinkedIn page. Please join, follow, keep track. We'll be posting about this project. Thank you so much for your attention. So we're out of time. I hope I'm here, in case anybody has questions. I know that people may have a meeting starting, but if anybody has questions, please.
There is a question in the chat.
Yeah. Okay, right. Sounds good. Why can't we fine-tune a foundation model on this is a good text? Okay, excellent question. Thank you for asking it. Okay, so practical limits, right? So we have not even evaluated this, because it's practically a complete nightmare once you put the model in production. So first of all, the AI risk committee has to approve any LoRa, right, which is the result of fine-tuning. Every time you make any change, you have to go back to the committee. So it's not a fluke where we encountered a client that made the process difficult. Every client is like I want to say nightmare, because I think it's actually people in these committees are doing a pretty good job, protecting the bank from questionable AI, right? But basically, you make a change to the code. Then 6 months later, like I guess in production, they have to approve this LoRa every time, right? So every time you have a LoRa, it's considered to be a new model. It has to be approved and go through all of these approvals. That's the standard in most banks. If your firm does not have that, maybe you're in a small hedge fund or even a large hedge fund, and the process is simpler. In a bank, that's the norm, right? If that's not the case for you, you're lucky. Second thing is, even if you overcome this hurdle, loading a LoRa does not go well with time sharing, right? So normally, if you're in the cloud, especially, like if you are doing it for the purpose that you can go outside, sometimes you can go outside in a private cloud, like for example, or in your firm's cloud, like Azure, for example. In Azure, you can run OpenAI. Also, in most clouds, you can run, of course, open source llamas because there are GPUs. So if you are time sharing with other people in the bank, it's very low cost to make a stateless call. Next second, somebody else makes a stateless call. GPU is very efficiently time sharing these calls. And this trade entry is a burst exercise, right? So the trade comes in, you have 2 minutes of intense calls, then you wait until the next trade comes in. You're not occupying the GPU. You don't need your private GPU, which is very hard to get right now, right? It's very expensive and they're in short supply. With the LoRa, you need to load the LoRa and unload the LoRa. A, it takes time. B, we found that loading and unloading LoRa's is something that at least today, a typical bank will have a timeshare GPU with stateless calls. And there are all kinds of frameworks for this. That's pretty commonplace. Loading and unloading LoRa's is a challenge for IT departments, at least today. So we have not investigated it because we knew that whatever we do with fine tuning, right, we stopped doing fine tuning because we found that we cannot deploy in production. That's the short answer. Right. Any financial institution adopted these techniques? Yeah, all of our clients basically is part of our compatible platform. So it's part of our platform. Basically, we make it available to all of our clients, and about a third are using it for trade entry. So it's basically, and also we have some users of the open source package. So yeah, I mean, it's a lot of it is adopted, and some of the banks adopted our whole trade entry thing. Other banks adopted the Convince package, which is Convince is a package for better instruction following for AI that basically has tools for measuring and fighting these cognitive biases. By the way, we're planning a new release pretty soon. So Convince is the package where you build your own trade entry, but you use a wrapper around AI, and it's called Convince because we convince the model to do the right thing. Right, so it's a wrappers to prevent biases, to make sure that the model does a reliable answer, right? So yeah, absolutely. I mean, it's being adopted, right? It has been adopted. Have you tested incorporating an MCP server? What's an MCP server? I'm sorry, I'm probably illiterate IT person here, for which I apologize. What's an MCP server? Sorry. Oh, model context protocol. We have not done it. In fact, I have to confess I'm not familiar with this, so but I will look it up. Thank you for bringing it up. But we haven't done it. I cannot even say that I'm have good understanding of what it is. But I'll look it up. Thank you. Any other questions? If you were talking about like having sort of like notebook LM, right, and ours basically a server where it provides context to AI, then the answer is yes, but we don't call it an MCP server, right? So we have what's called a corrective few shot, where we find when the model goes wrong, we find similar examples when it previously went wrong and was corrected, right? And we provided this, it's called corrective few shot. So I had actually a screenshot on that before, but I went over it very quickly and I did not elaborate. So when I post the slides, you will be able to find a reference to corrective few shot and generally how you can use the existing body of data to guide AI. And if that's what you're asking about, then we have used it, but we didn't call it by that name. Any other questions? Last chance. Going once. All right. So I think no other questions. Shall we perhaps conclude the session?
Sounds good. Thank you, Alexander. Yeah, so we'll leave it at that. And as you said earlier, if anybody does want to see a much longer and more in-depth version of this, then feel free to come along to our Quant Finance conference in September in Sicily. Always a good excuse to get to Sicily. So yeah, and obviously we'll have 3 days of talks and workshops, so there'll be something for everybody there. Otherwise, thank you, Alexander.
Thank you, and look forward to the conference.